Hello, my name is Improper, your regular tutor. We are still in the series of our teachings on mathematics. I want you to bring your book and your Bible closer to you so that you jot down all the points that we are going to make. Before we start, let's look at the format of the teaching. The subject is mathematics and the topic is partial fractions, behavioral objectives. At the end of this teaching, the students should be able to define partial fractions. The students should be able to resolve algebraic rational function into partial fractions. The students should be able to resolve algebraic rational function of linear factor into partial fraction. They should also resolve algebraic rational function of one linear and nonlinear factor. They should resolve algebraic rational function where the denominator is repeated factor. They should do other problems involved in partial fraction. These are the objectives that we are going to look at. Before we define partial fraction, let's look at illustrations that will help us to understand what partial fraction is. Now, consider the rational numbers. Consider the rational numbers 3 all over 4 minus 2 all over 3. Now consider these fractions. What can I do if I have this kind of fraction in mathematics? I will take the LCM. LCM of 4 and 3 is 12. Now by the time 12 will divide 3, I will have 3. And then 3 times this will give me 9. By the time 12 will divide 3, I will have 4. 4 times 2 will give me 8. So I have minus 8, which is equal to 1 all over 12. Therefore, 3 all over 4 minus 2 all over 3 is equal to 1 all over 12. Now, this one here is the same as 1 all over 12. It means these two fractions now will give you the same fraction of this type. Now, this fraction is the partial fraction of this one, this whole fraction. That is number 1. Now, let's extend it to algebraic function, such as if we have 4x minus 3, then we have 2x minus 1. Now this one is algebraic functions, algebraic rational functions. Suppose you want to take LCM. LCM will be x minus 3 and then x minus 1. Going this way, we will have that 4 times x minus 1. Of course, this one will cancel here, so we use this to times 4. Minus 2x minus 3. Look at that. Which means it will be equal to 4x minus 4 minus 2x plus 6 all over x minus 3 and x minus 1, which is the same thing as 2x plus 2 all over x minus 3 x minus 1. So in this way, we see that these rational fractions, which is 4 all over x minus 3 minus 2 all over x minus 1 is equal to this single rational algebraic function 2x plus 2 all over x minus 3 x minus 1. So this one here, this left hand side, is the partial fraction of this right hand side. That is what we call partial fraction. This side now, this side is 2. So this one now become 1. So we will be asked to resolve this one into partial fraction. That is all what we are going to do. Resolve this into partial fraction. And so that will lead us to the diminution of partial fraction. Two or more algebraic fractions resulting from a single algebraic rational function are called partial fractions. Two or more algebraic rational, very important to put that, rational fractions resulting from a single algebraic rational function are called partial fractions. It is done, the method of resulting a rational algebraic fraction into partial fraction is by certain rules depending on the nature of the denominator of the algebraic rational function. Yes, so two or more algebraic rational fractions resulting from a single algebraic rational function are called partial fractions. The method of resulting a rational algebraic fraction into partial fractions is by certain rules depending on the nature of the denominator of the algebraic rational function. Now, we have the denominator when, number one, when we have linear factor. Number two, when we have linear and non-linear factors at the denominator. We use another pattern for that. Another one, when we have repeated factor at the denominator, then we can also look at irrational fraction where we have improper fraction. So these are the ones that we are going to look at, so that we will know different ways of resolving algebraic rational fraction into partial fractions. Linear factor, when algebraic fraction has linear factor at the denominator. Now, to resolve an algebraic fraction of the form ax plus b all over cx plus d, then we have ax f. Now you see we have linear because the unknown here is linear, where a, b, c, d, e, f, the constants. So to resolve an algebraic fraction of the form is into partial fractions, assume partial fractions of the form a all over cx plus d plus b all over ex plus f. If we have any algebraic fraction that the denominator is linear, then we will assume a partial fraction of this form a all over cx plus d and plus b all over ex plus f. I've told you that c, e, f, they are constants. Alright. Now let's take example and see how you can do it. So, example, resolve into partial fractions x plus 1 all over x minus 2 and times x minus 1. Now we see that the denominator of this algebraic fraction is linear. That is, the highest power of the unknown is 1. Alright. So let's take the solution. We have x plus 1 all over x minus 2 x minus 1. And we say that we have to assume a partial fraction of the form a plus b all over this. So it will be equal to a all over x minus 2 plus b all over x minus 1. That is what we are saying. Now I'm going to use a method that we call cover-up method. After that, I will use comparing coefficients method. We can use this method to solve any algebraic rational function that the denominator is linear into partial fraction. We can use that to resolve into partial fraction. So we now see that x plus 1 all over x minus 2 x minus 1 will be equal to, now if I take LCM of this, I will have x minus 2 x minus 1. So going this way, x minus 2 will cancel x minus 2. So I will have a bracket x minus 1 plus b. Now going this way, we'll have x minus 2. Now you see that x minus 2 times x minus 1 is the same to the right hand side, x minus 2, x minus 1. So when we have the same like that, it means this side can cancel this side. See the only thing that remains, the upper one. So we can now see that x plus 1 is equivalent to a x minus 1 plus b x minus 2. Now by cover-up method that we are saying, we are going to put x is equal 1. You know how? We want to make this place 0, and we see minus 1 here. So for us to make it 0, we must put 1. When you say 1 minus 1, it will be 0. So that a can go out, and then we get the value of b. So if we put x is equal 1, then we have 1 in this place plus 1 is the same as a bracket 1 minus 1 plus b 1 minus 2. So what do we have? We have 2 will be equal to a. Of course, this one will be 0. That is a times 0 plus b times minus 1. 1 minus 2 is minus 1. Which means that 2 is equal to minus b. It implies that b is equal minus 2. Because if you make b subject of the formula, this will go here. When you divide by this, you have minus 2. Alright. Now, we can also put x is equal to, you know why? We are putting 2 here. So that 2 minus 2 will give us 0, and then we get the value of a. So if I do that, I will have from here that 2 plus 1 will be the same as a bracket 2 minus 1 plus b bracket 2 minus 2, which means 3 is equal to what? A, that is 2 minus 1 will give me 1, plus b times 0, 2 minus 0. 2 minus 2, which is 0. So this one will go, and then we will have that a is equal to 3. 1 times a is a. So a is equal to 3. Therefore, the partial fraction of x plus 1 all over x minus 2 and x minus 1 is the same as, we said a all over this plus b all over this. So we have the values of a. A here is 3 all over x minus 2 plus b was minus 2. Okay, so we have minus 2 all over x minus 1. So this is the partial fraction of this. That is how we can resolve it. But we can also look at it as using a comparing coefficients method. There is another method we say comparing coefficients. That is method 2. I know that, I will start from here. I know that x plus 1 is equivalent to a bracket x minus 1 plus b bracket x minus 2. So if I do that, if I multiply this, I will have ax minus a plus bx minus 2b. X plus 1 is equal to this. Which means if I collect these terms that carry x, then I will have a plus b, or let me make it clear, ax plus bx here and here, minus a minus 2b minus a minus 2b. Okay, x plus 1 is equal to this. Now, I can factor out something here. It's common. I have a plus b x, so that x times b will give me bx, x times a will give me ax. Okay, minus a minus 2b. x plus 1 is equal to this. Now, comparing coefficients. If I compare the coefficients, I will have, you see, look at this. The coefficients of x here is a plus b. The coefficient of x here is 1. So if I look at x, I see that a plus b is equal 1. Call that one equation 1. Now if I look at constants, minus a minus 2b, they don't have variable here. And another constant here is 1. So I look at that minus a minus 2b is equal 1. Call that one equation 2. Now if I solve it simultaneously, of course we know in simultaneous equation, before you remove variable, the coefficients must be equal, and we have equal coefficients here. So what will I do to remove a is to add. I'm going to add 1 and 2. If I add 1 and 2, you see, I have minus 2, yes, minus 2 plus minus 2b plus b will give me minus b. So I have minus b, because this one will go. Minus b will be equal to what? 2, which implies that b is equal minus 2. Have you seen that? So, which is c minus 2 that we have in this one. Then we are going to put b is equal minus 2 in 1. This is equation 1. So we have that a plus b is equal 1 will become a plus minus 2 is equal 1. So that a will be equal to 1 plus 2. This one will turn to this side. And then we have that a is equal to 3. Therefore, x plus 1 all over x minus 2 and x minus 1. The partial fractions of these is 3, that is this a, all over x minus 2 minus 2 all over x minus 1. This one is comparing coefficient method. This one was cover-up method, the first one that we used. So they still give us the same results. This is how we solve partial fraction in linear factor. It's just very simple as that. We want to look at linear and nonlinear factor. When we have algebraic rational fraction, which the denominator has one linear and one nonlinear factor, how can we resolve it? Right. To resolve, a rational algebraic function of the form ax plus b all over cx plus d, then we have dx squared plus f into partial fractions we will assume partial fractions of the form a over cx plus d plus bx plus c all over ex squared plus f. That is what we will assume. We will assume a partial fraction of this one. The other one we say a plus b. But in this one where 1 is non-linear, especially when it is quadratic factor, like I have quadratic here, then I will do it in this way. Now, let's take an example of this. So let's take this example. Express 8x squared minus 19x minus 24 all over x minus 2 times x squared minus 2x minus 5 in partial fractions. Now, we take the solution. We have seen that the denominator here is one linear, one quadratic. So this one is non-linear, while this one is linear. So that's why we say if we have something like this, that is 8x squared minus 19x minus 24 all over x minus 2, then we have x squared minus 2x minus 5. We will assume a partial fraction of the form a all over x minus 2 plus bx plus c all over x squared minus 2x minus 5. Yes. See, we will assume like that. It means that the quadratic factor will carry bx plus c up. Remember, when we had linear factor, this one carried a up, the other one carried b. But for quadratic factor in this nature, to carry bx plus c. Alright. So, now, we know that this thing will be the same as 8x squared minus 19x minus 24 will be equivalent to a x squared minus 2x minus 5 plus bx plus bx plus c, and we also have x minus 2. You know, I'm going straight because we will take LCM of this. LCM of this. This will cancel the LCM, so we use this and times a to have this. Going this way, you use this to times bx plus c. So I'm just going straight. Now, this will give us 8x squared minus 19x minus 24, which is equal to, now if I use this, if I use this to times, I'll have 8x squared minus 2ax minus 5a plus, now this way, I will have, this times this will give me bx squared, then this time is minus 2bx, then this time this will give me plus cx, this time will give me minus 2c. Expansion of that bracket, these two brackets will take from here. Now, if it is so, it means we can collect this once, we can collect like terms, so I carry power 2. So we have ax squared plus bx squared. Now let's deal with the ones that have x. Minus 2ax minus 2bx plus cx, then minus 5a, yes, minus 2c. So if we do that, we can look for the common term. Here, the factor out what is common, x squared minus, okay, then we have minus 2a minus 2b plus c. We factor out x also, because we use this and time this to get back this, use this and time this to get back this, use this and time this to get back this. So we just factor out the common variable here. Now we have minus 5a minus 2c. That means 8x squared minus 19x minus 24 is equal to this. Now we can compare coefficients. Comparing coefficients, we compare the coefficients, we see that a plus b is equal to 8. Call that one equation 1. Is it a plus b? Look at a plus b. That is the coefficient of x squared. And the coefficient of x squared here is 8. So a plus b is equal to 8. Now we can also look at the coefficients of x from this right hand side and look also from the left hand side. We see that minus 2a minus 2b plus c is equal to minus 19. Call that equation 2. Minus 19 is the coefficient of x for the left hand side, and then minus 2a minus 2b plus c is the coefficient of x at the right hand side. Now when we look at the constants, we have that minus 5a minus 2c is equal to minus 24. So we have what? Equation 3. So you have 3 equations now to solve. Now, but from 1 right here, a is equal to 8 minus b. Yes, that is transferring here to this side, a minus b. And we also see that from equation 3, which is this, we can make c subject of the formula. And then we have that minus 2c will be equal to minus 24 plus 5a. Look at that. You just transfer minus 5a to this side. So we return to plus 5a. Then c only will be minus 24 plus 5a. Yes. All over 2. You see, this minus here now is the minus for this minus 2. So this thing will give me 24 minus 5a all over 2. That is c. That is c. Now I'm going to put a is equal 8 minus b, and c is equal 24 minus 5a all over 2 in 2. I'll put it in equation 2. You know, equation 2 says that minus 2a minus 2b plus c is equal minus 19. And so if I do that, it means that minus 2a, a is 8 minus b, minus 2b plus c, and c is 24 minus 5a, yes, all over 2, that is equal to minus 19. Now that means what we have here is this time this gives us minus 16 plus 2b minus 2b. Then here we have plus 24 minus 5a all over 2. Of course, this and this can go. So what we have becomes, we have minus 16 plus 24 minus 5a all over 2 is equal to minus 19. Here, of here, we have minus 32, because this is over 1. Minus 32 plus 24 minus 5a is equal to minus 19. Now, minus 32 plus this will give us minus 8 minus 5a all over 2. Yes, which is equal to minus 19. Yes, because the LCM of this and this, if you use 2 and times it, you have minus 32. So going this way, you have 1 times 24, say give it here, 1 times 5a, say give it. So you have this. Now if I cross multiply, then I will have minus 8 minus 5a is equal to minus 38. That is 2 times 19, give us 38. So that minus 5a will be equal to minus 38 plus 8, which means that minus 5a will be equal to minus 30, and that A will now be minus 30 divided by minus 5, which is 6. So A is 6. A is 6. We can also solve for B and C. But we know that from equation 1, that A plus B was equal to 8. So now that we have A to be 6, we put 6 plus B is equal to 8. So that B will be equal to 8 minus 6, which is 2. So now B is 2 and A is 6. So we can now put A and B in equation 2. Then we will get C. So equation 2 says that minus 2A minus 2B plus C is equal minus 19. Yes. So we put the values here. We put minus 2. A is 6. Minus 2. B is what? B is 2. Plus C is equal minus 19. So we have that minus 2 times 6, minus 2 times 2, that is replacing a value of A and value of B, plus C is equal to minus 19. Now we can continue from here, and we say minus 12, that is 2 times 6, minus 4 plus C will be minus 19. So that we have that C will be equal to minus 19 plus 12 plus 4. You know, this 12 minus 4, they are running to this side, so they become positive. And if we do that, we see that 12 plus 4 is 16. So 16 minus 19 gives us minus 3. So C is minus 3. Therefore, the partial fractions of the function x squared minus 19x minus 24 all over x minus 2 times x squared minus 2x minus 5 is equal to, you see, in the place of A, our A is 6 all over x minus 2. Then B gives us 2 plus 2x. You know, we say bx. So we put 2 in place of B. Bx minus C, because C is minus 3. So we have minus 3 all over x squared minus 2x minus 5. So this is the partial fraction of this. And that is the way it is resolved. Very simple. So we are looking at repeated factor. To resolve an algebraic fraction of the form ax plus b all over all over c x plus d raised to n. You see, when we have something like this, it's raised to power n. We will assume as into partial fractions. We will assume a partial fractions of the form a1 all over cx plus d plus a2 all over cx plus d squared plus, we will go like that till we have an all over cx plus d raised to the power n. You know, this is generalization. You assume a partial fraction of this form. A1 all over cx plus d plus a2 all over cx plus d squared. Then we continue like that, meaning the next will be a3 all over cx plus d cubed. Then we go again till we have an all over cx plus d raised to the power n. Let's take example of an algebraic fraction that has a repeated factor. Resolve into partial fraction 32x squared minus 28x minus 5 all over 4x minus 3 raised to the power 3. Now the solution. 32x squared minus 28x minus 5 all over 4x minus 3 cubed. And we say that we have to assume a partial fraction of the form a all over 4x minus 3 plus b all over 4x minus 3 squared plus c all over 4x minus 3 cubed. See that? So, if here were to be raised to the power 5, that is what we will do. The next one will be 4x minus 3 raised to the power 4. The next one will be 4x minus 3 raised to the power 5. Now, as it is, if we take the LCM, we know that 32x squared minus 28x minus 5 will be equivalent to a times 4x minus 3 squared. Then we have 4x this times this plus b times 4x minus 3 plus c. We use this times this plus c, which is the same as 32x squared minus 28x minus 5. Then a is by binomial expansion. Binomial expansion, we have to watch our lectures on binomial expansion. You see how I'm going to expand our 4x squared plus, alright, we have minus 2 times 4 is 8. 8 times 3 is 24. So we have minus 24x plus 9 plus 4bx minus 3b plus c. How? This times this will give me 4bx. This times this will give me minus 3b. So in this place, I will have that a. I'm going to expand this. I have 16x squared minus 24x plus 9 plus 4bx minus 3b plus c. Then we use a to times here, where we have that 16ax squared minus 24ax plus 9a plus 4bx minus 3b plus c. That is 32x squared minus 28x minus 5 is equal to this. Then collecting like terms, the ones that carry x, we'll collect them. We see that we have that 32x squared minus 28x minus 5 will be the same as 16x squared minus 24ax plus 4bx plus 9a minus 3b plus c, which is the same as 16x squared minus 24a plus 4b. So what happened here is that minus 24a plus 4b will times x. See, I'm factoring out x because x is common to this, plus 9a minus 3b plus c. So here we can now compare coefficients. Comparing coefficients, you see here we have the 16a x squared. Here we have 16a x squared. So we have that 16a is equal to 32. We call that equation 1. 16a is equal to 32. That is the coefficient of x squared. And we also have that minus 24a plus 4b is equal to minus 28. Call this equation 2. Minus 28 is the coefficient of x at the left hand side. So minus 24a plus 4b is the coefficient of x at the right hand side. Then for the constants, we have that 9a minus 3b plus c is equal to minus 5. So we have three equations. And from 1, we know that a will be equal to 32 divided by 16, which is 2. The time we divide 32 by 16, we have a. And if we put a is equal to 2 in equation 2. Equation 2 here. Equation 2 is minus 24a plus 4b is equal to minus 28. So if we put a is equal to, then we'll have minus 24 times 2 plus 4b is equal to minus 28. So this times this will give us minus 24. So it will give us minus 48 plus 4b is equal to minus 28. Now 4b will be equal to minus 28 plus 48. Yes, because this is going to this place plus 48. And if we do that, we have that 4b will be equal to 20. So that b is equal to 20 divided by 4, which is 5. Now we are going to put b. We first put a is equal to b is equal to 5 in 3. Remember 3 says that 9a minus 3b plus c is equal to minus 5. So we have 9 times 2 minus 3 times 5 plus c is equal to minus 5, which is 18 minus 15 plus c is equal to minus 5. So we have here 3 plus c is equal to minus 5. So c is equal to minus 5 minus 3, which is equal to minus 8. So c is minus 8. We now see that the algebraic rational fractions 32x squared minus 28x minus 5 all over 4x minus 3 cubed is resolved to a partial fraction of the form a, which a is what? 2. 2 all over 4x minus 3 plus b, which is 5 all over 4x minus 3 squared minus 8 all over 4x minus 3 cubed. That is the partial fraction of this algebraic fraction. It's so simple as that. Next subtopic is improper fraction. When the degree of the numerator, the degree of the unknown on the numerator is equal or higher than, is equal or higher than the degree of the unknown at the denominator. Such algebraic function is said to be improper. Algebraic function. Now to resolve into partial fractions, we divide the numerator by the denominator using long division method. Long division method is taught in polynomials. So if you can watch our lectures on polynomials, you see the method of long division method, where you can use long division to divide algebraic function or polynomial function. So we do this, we divide the numerator by the denominator using long division method. Now let's look at example of this type of fraction, which is improper. An algebraic function where the degree of the numerator is higher than the degree of the denominator. Resolve into partial fractions. X raised to the power 4 all over x plus 1 raised to the power 3. So we see that x raised to the power 4 all over x plus 1 cubed. It can be the same thing as x raised to the power 4. You see this one? By binomial expansion, we have x raised to the power 3 plus 3 x squared plus 3 x plus 1. How? You can watch our lectures on binomial expansion. You will see how we have this, because x plus 1 cubed is the same as writing x plus 1, x plus 1, x plus 1. So you begin to times these two first before you add this one. But if you know binomial expansion, you don't need to do waste time. You can just expand it like this, knowing that this first one will raise the power n, which is power 3 here. and then you say 3, then x will reduce to power 2, and then 1 will become 1 times 3, x will reduce to power 1. Watch our lectures on binomial expansion. You will get it right, and you will get it very well. You will enjoy the lecture. So, if it is so, then we still see that the degree of the variable at the numerator is higher than the degree of the variable in the denominator. So we can use long division method to divide it. By long division method, we have something like this. So we have x raised to the power 4 will divide x cubed plus 3x squared plus 3x plus 1. Now, x raised to the power 4 divided by x raised to the power 3 will give us x. Look at x raised to the power 4 means like this, divided by x raised to the power 3, which is 3. So all these can cancel, remain only 1. That's how we get it. Then this times this will give us x raised to the power 4. Alright. This times this will give us plus 3x raised to the power 3. Then x times 3x will give us 3x squared plus x, that is x times 1. Now we are going to subtract. If we subtract, here nothing is here, so it's just 0 minus x, so we have minus x. Here 0, nothing is here, so minus 3x squared, so we have minus 3x squared. And then here we have minus 3x cubed. Now we can divide again by this. If we divide this, minus 3x cubed divided by x cubed will give us minus 3. Minus 3 times x cubed will give us minus 3x cubed. Okay. So minus 3 times this will give us minus 9x squared. Minus 3 times 3x will give us minus 9x. Minus 3 times 1 will give us minus 3. Now we can subtract again. The same thing happened here. There's 0. So 0 minus minus 3 will give us 3. Plus 3. So here we have plus 8x. How? Because minus x minus 9 will make here plus 9. So plus 9 minus x. Plus 9x minus x will give us plus 8x. Now here we have minus 3x squared minus 9x squared. So it will give us 6x squared. Alright. Then what we have here is minus 3x squared minus 3x squared. So that is 0. This is what we have. So we will now have, what we now have becomes x raised to the power 4 all over x plus 1 cubed is the same as 6x squared plus 8x plus 3 all over x plus 1 cubed. Now, resolving 6x squared plus 8x plus 3 all over x plus 1 cubed into partial fraction. We will assume a partial fraction of the form a all over x plus 1 plus b all over x plus 1 squared plus c all over x plus 1 cubed. So we can now see that 6x squared plus 8x plus 3 is the same as a bracket x plus 1 squared plus b x plus 1 plus c. So that by expansion we have x squared plus 2x plus 1. This is the expansion of this place. Then use this to times we have bx plus b plus c. Then ax squared, that is using this to times this plus 2ax plus a plus bx plus b plus c. Then we do that, we can bring like terms to have ax squared plus 2ax plus bx plus a plus b plus c. Now if we compare coefficients, comparing coefficients, we will see that a is equal to 6 because the coefficient of x squared here is 6 and the coefficient of x squared here is 8. And we also see that for the coefficient of x, if we factor out x, that is, we have 2a plus b. You see that? So x squared. Then the coefficient of x becomes 2a plus b. Alright? A plus b plus c. So that will give us 2a plus b is equal 8 because the coefficient of x in this side is 8. Then for the constants, we have a plus b plus c is equal to 3. So we have 3 equations. Now we are going to put a is equal to 6 in 2. Remember, equation 2 says that 2a plus b is equal to 8. So 2 times 6 plus b is equal to 8, which means 12 plus b is equal to 8. So b is 8 minus 12, which is equal minus 4. B is minus 4. Then we are going to put a is equal 6, b is equal minus 4 in 3. Question 3 is a plus b plus c is equal to 3. So a now is 6, b is minus 4 plus c is equal to 3. So what we have is that c will be equal to 3 minus 6 plus 4. So c is equal to 1. That is 3 plus 4 is 7 minus 6, we have 1. Therefore, the algebraic fraction s raised to the power 4 all over s plus 1 cube is equivalent to the partial fractions. Then we'll now come back and pick this one that we got during long division. We now pick that one and come. See, it's equal to x minus 3 plus then these ones. These ones here we have a, and a is 6, so we say 6 all over x plus 1. Then we also have b is minus 4 all over x plus 1 squared. Then we also have 1 here plus 1 all over x plus 1 cube. That is how we can resolve it into partial fraction. We are going to look at denominator with different linear factors. Example, resolve into partial fractions. 8x squared minus 14x minus 10 all over x cubed minus 4x squared plus x plus 6. Now let's take the solution. The denominator is x cubed minus 4x squared plus x plus 6. Now we want to assume a number that will make this denominator 0. We want to look at the 0 of this particular polynomial. So if you watch our lectures on polynomials, you really know what I mean by 0 of a polynomial. A number that will make this particular polynomial 0. Now assume x is equal 1. Then I will have 1 cube minus 4, 1 squared plus 1 plus 6, which gives 1 minus 4 plus 7, which is equal to 1 plus 7 is 8 minus 4. So 1 is not the zero of the polynomial. I will also assume x is equal minus 1. If I do that, then I will have minus 1 cube plus minus 4 minus 1 square minus 1 plus 6, which will give me minus 1 minus 4 minus 1 plus 6. So I have minus 1 minus 4 is minus 5 minus 1 minus 6 plus 6, which is 0. So minus 1 is the 0 of the polynomial. And so if x is equal minus 1 is the 0, then x plus 1 is a factor. It's a factor of this particular polynomial. If you watch our lectures on polynomial, you really understand what we mean by the 0 of the polynomial and the factor of the polynomial. Now, then we can use this one to divide this particular polynomial function so that we get other factors. That can be done by long division method. So x plus 1 is a factor, and we want to divide x cubed minus 4x squared plus x plus 6. So x cubed divided by x will give me x squared. X squared times x will give me x cubed. X squared times 1 will give me plus x squared. Now I'm going to subtract, so I'll have 6 plus x. Now this is what? This will give us minus 5x squared. That is minus 4x squared minus x squared. Then x cubed minus x cubed will be 0. And let's divide this again. We'll have minus 5x. Minus 5x times x will give us minus 5x squared. Minus 5x times 1 will give us minus 5x. Now we have 6 plus, this will give us 6x, because x minus will make this one plus 5x, so we have 6x. Now we will divide again. 6x divided by x will give us 6. 6 times x will give us 6x. 6 times 1 will give us 6. So if we subtract, everything will become 0. So it means what we have here now becomes we have it in this way: x plus 1 as a factor and x squared minus 5x plus 6 as a factor. But we can resolve this using quadratic equation, this particular factor. And then we have x squared minus 2x minus 3x plus 6. You know, when we want to solve quadratic equation, we look at two numbers that will add to get the middle term, and when we multiply, you get the last term. So it will be minus 3x minus 3. So which is x squared minus 2x. I will group this one. 3x plus 6. I will group it. Then what is common here is x. So we have x minus 2. Then here we have 3x minus 2. Then if I do that, then x minus 3, that is this and this. The outside one is a factor, and then x minus 2 is a factor. Therefore, the factor of the denominator becomes x plus 1, x minus 2, x minus 3. This is what I have, the factors. So we can now see that 8x squared minus 14x minus 10 all over x cubed minus 4x squared plus x plus 6 is the same as writing 8x cubed minus 14x minus 10 all over x plus 1, x minus 2, and x minus 3. So this is the same as writing this way. So this one now is what we are going to resolve into partial fraction, and we see that it has different linear factors. It has different linear factors. So But we know that in linear factor, when we started with linear factor, we have the algebraic fraction of this form all over x plus 1, x minus 2, and x minus 3. That we will assume a partial fraction of the form a all over x plus 1 plus b all over x minus 2 plus c all over x minus 3. We assume a partial fraction of that form. And if it is so, it means 8x squared minus 14x minus 10 will be equivalent to, we will have a bracket x minus 2, x minus 3 plus b. I'm taking LCM. If I take this LCM, this one will cancel the LCM, so it remains only this. I use it and times a. The same thing will happen here. This one will not follow. So if I'm talking about b, then I will have this and this. X plus 1, x minus 3 plus c. So now that I'm talking about c will not, this denominator of c will not be there. So I have x plus 1 and then I have x minus 2. Alright. So if I have this, I'm going to put x is equal to, you know why? Because if I put 2 here, x is equal to, then everything here will be 0. When this one is 0, a will be 0. And at the same time, when I put it here, 2, so this will be 0, then I will get the value of b. So if I put x is equal to, I will have 8 times 2 raised to the power 2 minus 14 times 2 minus 10 will be equal to a bracket 2 minus 2 x is 2 minus 3 plus b 2 plus 1 2 minus 3 plus c 2 plus 1 then 2 minus 2. So what do we observe? Observe that this place will become 0. So this, everything here and everything here will go because here will become 0. Now is 32. As 32 is 8 times 4 because 2 squared is 4. So 4 times 8, 32 minus 28 minus 10 will be equal to, this one will be minus 1. That is 2 minus 3 is minus 1. Minus 1 times 3, that's 2 plus 1, give us minus 3. So minus 3 times b give us minus 3b. Alright. Then here, minus 28 minus 10 is giving us minus 38. So 32 minus 38 is equal to minus 3b. This gives us minus 6 is equal to minus 3b. So b is equal to minus 6 all over minus 3, which is 2. Now, you can also put x is equal to minus 1. You know how? By the time we put x is equal to minus 1 here, we put minus 1 here. Then, this place will become 0. The whole of this will also be 0 because here will become minus 1. And then we will solve for the values of x, for the value of x. Alright, so put x is equal to minus 1. We'll have 8 minus 1 squared minus 14 minus 1 minus 10 will be equal to a minus 1 minus 2 minus 1 minus 3. That is, I'm putting it here, this value. So everything here from b is 0 because when I have minus 1 here, it will give me 0. So all those places are 0. But what I have here is 8. Minus 1 squared is 1. Then I have plus 14 minus 10 will be equal to, and look at this, minus 1 minus 3 is minus 4. So this one is minus 3 in this bracket. This one is minus 4. Minus 4 times minus 3 will give us 12. 12 times 8 will give us 12a. So what we have here is 14 plus 8. 14 plus 8 is 22. 22 minus 10 will give us 12. So 12 is equal to 12a. Meaning that a is equal to 12 all over 12, which is 1. So a is 1. Now, we can also put x is equal to minus, no, x is equal to 3. Put x is equal to 3. Now, if we put here x is equal to 3, we'll have 3 minus 3, which is 0. So everything here will be 0. And when we come here, we'll put 3. 3 minus 3 will make this 0. So what we'll have here will be the value of c. So we put that, we now have that 8 3 squared minus 14 times 3 minus 10 is equal to c 3 plus 1, and then we have 3 minus 2. Now, this square, 3 squared is 9, so we have 8 times 9 minus 14 times 3 minus 10. Then here, the whole of this is 4. 3 plus 1 is 4. 3 minus 1 is 1. So 1 times 4 is 4. And 4 times here will give us 4c. 4 times c. 4c. Now, 8 times 9 will give us 72. Then 14 times 3. 14 times 3. 3 times 4 is 12. Carry 1. 3 times 1, 3 plus 1. We have 4. So we have 42 minus 42 minus 10. So minus 42 minus 10 will give us minus 52. Alright, 4c. So we have 72 minus 52 is equal to 4c. And 72 minus 52 will give us 20. 20 will be equal to 4c, which means c is equal to 20 divided by 4, which is 5. So c is 5. C is 5. Then it means that the partial fraction 8x squared minus 14x minus 10 all over x plus 1, x minus 2, and x minus 3 will be equal to a, and then we have the value of a as 1. A is 1 here. A is 1 as 1 all over x plus 1 plus b. Our b is what? B is 2. 2 all over x plus 1. Then we also have c. C is 5 plus 5 all over x. Okay, we have x minus 2. This is x minus 2. And this is x minus 3. So this is the partial fraction of this. We can resolve it in that way to get the partial fraction of such algebraic fraction where the denominator has different factors. So this is how far we can go in this package. I will urge you to get our lectures on different packages where you can be familiar with mathematics. Mathematics is very simple to deal with. So get all the packages, watch them one after the other, and you will be very, very happy